Hey all, welcome to Homeschool. And we started with MCQ series on all 10th science chapters, isn't it? I have already covered MCQs on acids, bases and salts, where the link is provided in the description. You can go and check it. And today I'm doing MCQs, the top MCQs which have covered all the topics in a chapter on the chapter called Metals and Non-Metals. Okay. So we have a 20 MCQs here. Let us discuss one by one in a detailed way. Clear? So the first MCQ, which of the following pairs will give displacement reaction? Okay. See, normally you must understand the whole concept of displacement reaction. Reactive metal can displace the less reactive metal, isn't it? So in other words, I can say the metals which is more reactive can displace the metal which is less reactive. And how do you know that which metal is more reactive and which metal is less reactive? It is by reactivity series. So here you decide the answers of such questions based on reactivity series. So how do you remember the elements in a reactivity series? I have a beautiful shortcut here which was explained in the chapters of chemical reactions and equations if you want it in a detailed way. Now I'll just tell it in a shortcut way. That is, just remember the sentence, please stop calling me a careless zebra. Instead, try learning how copper saves gold. Right? So here P is what? Potassium. Potassium is more reactive element in our nature than sodium. In a reactivity series, first comes potassium, later comes sodium. Okay, C means it is calcium, M means magnesium, A is aluminium, C is carbon, right? And later Z means zinc, I is iron, T is tin, comes lead, L means lead, and later comes our hydrogen, and after that you have copper, silver, that is Ag, and finally gold. So this is the reactivity series. So just try to remember, please stop calling me a careless zebra. Instead, try learning how copper saves gold. Okay, so this is the shortest trick. And now the element which is more reactive can displace the element which is less reactive from the metal salt solution. Okay, so now let us check out with the options. First option was ferrous sulfate solution and copper metal. So can a reaction occur between copper and FeSO4? Right? Say this is a metal. If this metal has to go in the place of iron, this guy must be more reactive than iron. So is copper more reactive than iron? Check the position. Where is copper coming? Here. Where is iron coming? Here. No, right? Iron is more reactive than copper. Iron is more reactive than copper. Copper must be more reactive than iron to observe the displacement reaction. No, in this case, displacement reaction is not observed because copper is less reactive only than iron. Okay, the elements which are coming first are more reactive than the elements which are placed at the end. Okay, fine. So the first option cannot undergo displacement reaction. Coming to the second option, what is the second option? Copper metal reacting with AgNO3, right? And now check the nature of metals. Copper must be more reactive than silver. Then displacement reaction takes place. So is copper more reactive than silver? Where is copper and silver coming? Here. Yes, copper is front, right? So copper is definitely more reactive than silver. So displacement reaction is observed in case of option B. So which is the correct option here? Option B is correct answer. Right? So based on the reactivity series, you have to decide such questions based on the, which are coming on displacement reaction. Okay. Say third option, copper sulfate and silver they gave you, right? That is Ag plus copper sulfate. Here also displacement reaction cannot occur because Ag is coming here, copper is coming here. Ag is less reactive. So this guy cannot remove copper. It cannot displace copper. Okay. So what is the fourth option? Let us see. You have NaCl solution. And what is the metal you have? Copper. No, copper is somewhere at the end, right? Somewhere at the end. And see, sodium is somewhere here. So sodium is more reactive. Copper must be more reactive than sodium. Then only displacement occurs. But here copper is less reactive than sodium. So displacement reaction does not occur. Right? So that's all about, the questions on displacement reactions and reactivity series. See, it's my guess that you may expect this sort of questions. Okay, so for this you must definitely know the concept of reactivity series and displacement reaction. Don't just by heart the questions. When you know the concept, any question if they ask, you can able to answer it very, very easily. Okay, let us go for the second question. Which of the following methods is suitable for preventing an iron frying pan from rusting? You have a iron frying pan. If you want to prevent it from rusting, which is the suitable method? Applying grease. When you apply a grease, to some extent you can prevent rusting, but you can't apply a grease for frying iron pan. Frying iron pan can be used for cooking, isn't it? So when you are using something for a cooking, you can't apply grease, paint and all, right? So that is a wrong option. Second one, applying paint also you can't do for the vessels that you are using for cooking, right? No. Applying a coat of zinc, yes, it can be done by a chemical method called galvanization, right? So what do you mean by galvanization? It is applying zinc coating. It's a process where zinc is coated on iron. So chemically you are applying zinc coat on iron. So that zinc coat will not be removed that easily, just like paint and grease. So I think this is the best method to prevent the rusting of iron pan, right? So option 3 may be the correct answer. Option D is all of the above. It's not all of the above. You can't use grease in this case and you can't use paint also in this case. But you can use galvanization. That is, you can give a coating of zinc on iron utensils. Okay. So option C is correct. Let's go for the third question. Food cans are coated with tin and not with zinc because there are food cans which are coated with tin. Okay, not with zinc. Why they are asking? Zinc is costlier than tin. Second option, zinc has a higher melting point than tin. C, zinc is more reactive than tin and zinc is less reactive than tin. Look at our reactivity series. Where is zinc is coming and where is tin is coming? Zinc is here, tin is here. That means zinc is more reactive than tin, no? Right? So that is the reason. Tin is less reactive. That's the reason, food cans are coated with tin. So that tin will not be reacting with oxygen, vapor, whatever it is, right? But zinc is quite reactive than tin. That's why zinc cannot be used for the coating of food cans, right? So here, what is your answer? It's tin is best used. It's because zinc is more reactive than tin. So option C is the correct answer, because in the reactivity series, if you see, zinc is coming here in the front. That means zinc is more reactive than tin. That's why zinc is preferred more compared to zinc. Okay, when you have to give a coating for food cans. Fourth question, which of the following oxides is amphoteric? This is another important concept, that is amphoteric oxides. So can you give an examples for amphoteric oxides? One is Al2O3 and another one is zinc oxide. So both examples try to remember. So which is the option in this case? Definitely option B, right? MgO, Al2O3, K2O and A2O. So Al2O3 is the best example for amphoteric oxides. And try to remember the reactions of amphoteric oxide. So you have aluminium oxide reacting with acid. What do you get? You will get aluminium oxide, right? plus H2O. Similarly, when aluminium oxide reacts with NaOH, what do you get? This product is very important. NaAlO2 plus H2O you will get, right? So this is called as sodium aluminate. So aluminium oxide when reacts with acid, what do you get? Aluminium oxide when reacts with a base, what do you get? Both products are important. Maybe questions can be asked on this concept also. Okay, what is amphoteric oxide, by the way? Amphoteric oxide is the one which can react with both acid and base to give salt and water, isn't it? Fine. Let us go for the fifth question. Which of the following properties of aluminium are responsible for the same? That means why aluminium is used for making cooking utensils. We all know it's because it's having good thermal conductivity, right? The first reason is aluminium has good thermal conductivity. This is one important property of aluminium. The other one is it has high melting point. So these are the two reasons why aluminium is used for making cooking utensils. So now read out the sentences and select the option. First sentence, good thermal conductivity, yes. That means A sentence is correct. Second one, good electrical conductivity, no. C, it's because of ductility, no. Is it because of high melting point? Yes, yes. So A sentence is correct and D sentence is correct. So in which of the option A and D are correct? Option D, right? So option D is correct answer here. Okay, so very, very important and very famous question actually from this particular chapter. Sixth one. What happens when calcium is treated with water, right? Say calcium can react with cold water, right? Calcium on reacting with cold water, you will get calcium hydroxide plus hydrogen gas finally, right? And this is cold water. It can react with cold water and the reaction is not violent. Reaction is not violent, isn't it? And you know, one thing occurs when calcium reacts with water. After the reaction, you will observe the calcium pieces floating on the surface. Few of the calcium pieces will come and float on the surface. So why? It is because of hydrogen gas. Okay, lots of hydrogen gets generated, right? So these gas will bring unreacted calcium pieces onto a top. So hydrogen gas, hydrogen bubbles are bringing that unreacted calcium pieces onto a surface. Okay, so that's why calcium keeps floating, unreacted one, the one which has not reacted, no, that pieces will float on a surface. It's because of hydrogen gas. So this is the concept of calcium reacting with water. Okay, now let us see what they have asked in a question. What happens when calcium is treated with water? They gave some sentences. A sentence, it does not react with water. No, it is reacting with the water. It's a wrong sentence. B, it reacts violently with water. I mean, during the reaction of calcium with water, do you expect fire just like sodium and potassium? No, the reaction is not violent. I told you, right? Not violent. Violent. Okay. And the third sentence, C sentence, it reacts less violently with water. Yes, yes, C sentence is correct. Okay. And coming to the D, bubbles of hydrogen gas formed stick to the surface of calcium. Yes, the bubbles, hydrogen gas bubbles is the one which is bringing calcium onto a top and it makes the calcium to float on the surface of water. Okay, so it's because of hydrogen bubbles. So sentence D is correct, sentence C is correct. C correct, D correct. Which of the option has C and D correct? It is option D. In option D, you have C and D getting correct, right? So option D is the answer in this case. Clear? Fine. And let's go for the seventh question now. Generally, metals react with acids to give salt and hydrogen gas. Which of the given acids does not give hydrogen gas on reacting with metals except manganese and magnesium? right? See, HNO3, since it is oxidizing agent, right? You know, it will not give hydrogen gas on reacting with metals, right? So this is what the concept we studied. Say if you have a metal, when you treat it with HNO3, okay, what are the products you will get? You will get metal nitrate plus water you will get. Hydrogen gas will not come. Hydrogen gas gets converted into water because HNO3 is the oxidizing agent. You must remember the concept here, guys. Okay, not just by hearting the options here. This is the actual concept. Any acid when reacts with metals, you will get salt and hydrogen gas. But here you will get water. Salt will come, but water will come. Why hydrogen gas is not formed? Because that hydrogen is getting converted into water. It is because HNO3 is the best oxidizing agent. It oxidizes H2 into H2O. Okay. So now can you all tell me the option, right? So which is the option? Option C, HNO3. So which acid does not give hydrogen gas? It is HNO3, which will not give hydrogen gas on reaction with metals. Fine. Question number 8. Which one of the given properties is not generally exhibited by ionic compounds? So can you all tell me the properties of ionic compounds here? Ionic compounds are solids. They are soluble in water. They conduct electricity in liquid state or molten state. They do not conduct electricity in solid state, but they conduct electricity in liquid state, isn't it? So these are the properties that we studied for ionic compound. Now you read the question. Solubility in water? Yes. Property of ionic compound. Electrical conductivity in solid state? No, it cannot conduct. Okay, so here option B is correct. Ionic compounds do not conduct electricity. Do not conduct electricity in solid state. So they said which one of the given properties is not generally exhibited? Yes, electrical conductivity in solid state is not possible, right? So option B is correct. Okay. 9th question, very simple. Silver particles become black on prolonged exposure to air. This is due to the formation of, say, when silver reacts with sulfur present in the atmosphere, you will get Ag2S, and this is that black color substance that is deposited on silver particles. Okay, so our atmosphere will have sulfur. So Ag reacts with sulfur to give silver sulfide, which is black in color. So which is the option? Option C is the correct answer. Similar to this, the 10th question. If copper is kept in open air, it slowly loses its shining brown surface and gains a green coating. It is due to the formation of rusting of copper, right? So when copper is exposed to air, the brown color will fade away. You will observe green coating. It's because copper reacts with carbon dioxide in the atmosphere, and that copper gets converted into copper carbonate, and this is that green in color, right? So which is the option? Option B is the correct answer, right? And now let us go for the 11th question. See, the question is, generally non-metals are not lustrous. Yes, non-metals are not malleable, they are not ductile, they are not lustrous, they are not sonorous. We know the physical properties of metals and non-metals, right? Which of the given metal is lustrous? There are certain exceptions. See, the non-metal which is lustrous is iodine. Iodine is a solid and it's a non-metal, but it has a shiny nature. That's what we mean by lustrous. So what is the option? Sulfur, oxygen, nitrogen, iodine. So option D, Iodine. Option D, iodine is correct answer. Fine. 12th question. An element A is soft, can be cut with knife. Right? Element A is soft and can be cut with knife. The moment I said this, it should click in your mind that the elements are sodium or potassium. It can be sodium or potassium. Both are very much soft and they can be cut with knife. This is very reactive in air and cannot be kept open in air. It reacts vigorously with water. Identify the element. Yes, both sodium and potassium vigorously react with water. That's why, where are they kept? They are kept in kerosene. Note down this point. This is also very important. Sodium and potassium are always kept in kerosene because they are very much reactive in air. Which is that element they are asking? Look at the options. Option A has Mg. Option B has sodium. Yes, our sodium is the answer. Option C has phosphorus. P means phosphorus. It's not potassium, right? Our D is calcium. So option B is correct. That is sodium. Yes, the 14th question is repeated question. It's already I discussed. The greenish coating develops on copper utensils is due to copper carbonate that is formed. That is option A here, right? Anyway, we discussed it. Okay. Next, 15th question. Reaction between X and Y forms compound Z. Say, I'm talking about 15th question. There is X element reacting with Y element and you are getting some element Z. X has a property of losing electrons. So X has a property of losing electron and Y has a property of gaining electrons. So Y always gains electron. What do you call X as? Anything that loses electron is called metals, no? Anything that gains electron is called non-metal, right? So that means X is a metal and Y is a non-metal. That means reaction is happening between metal and non-metal. This is what you have to understand. Which of them is not shown by Z? Okay, which of the properties? Some properties are given in the option. So which are the properties not shown by Z? That means, see, when a metal reacts with a non-metal, what type of a compound is formed? So your Z is ionic compound. This is what we understood. Our Z is ionic compound. So which of the following is not a property of ionic compound, they are asking. So read the sentence. High melting point. A option, high melting point. Yes, it is a property of ionic compound. B has low melting point. No, ionic compounds always have high melting point. But in option B, they said has low melting point. So this is not a property. They asked which is not a property of Z. So option B, which they indicated as less melting point, that is not a property of Z. Yes or no? So what is the answer here? Option B is the answer. Let us read out the next options also. C, conducts electricity in molten state. Yes, ionic compound's property itself, right? And D, occurs as a solid. Yes, ionic compound can occur as a solid. So high melting point is a property. Conducts electricity in molten state is a property of Z. Occurs as solid is a property of solid. But having less melting point is not a property. So here option B is the answer. Okay, fine. 16th question. Amalgam is an alloy of, no need to think only, amalgam means it is an alloy of mercury. Mercury in combination with other element, that particular alloy is called as amalgam. Fine. 17th question. The process in which a carbonate ore is heated strongly in the absence of air to convert it into metal oxide is called, right? What do we call it as? Very famous definition that we studied called calcination. Here in calcination, we convert carbonate ore into oxide ore, right? And here we heat this carbonate ore in the absence of air or oxygen, right? And you have another thing called roasting. So So what is roasting? In our roasting, sulfide ore is getting converted into oxide ore and we heat in presence of air, right? So they may ask you a question on calcination or they may ask on a roasting. So both meanings are important to understand here. Coming to the 18th question. Look at the question. Oxides of moderately reactive metals like zinc, iron, nickel, tin, copper, etc. are reduced by using moderately reactive metals are reduced by using carbon as a reducing agent. Remember, carbon as reducing agent. Okay, so for these things, carbon is used as a reducing agent, and to some extent, aluminium is also used as reducing agent. So both are correct only here. So you will have a confusion between option A and option C, because you see the option aluminium as reducing agent, sodium as reducing agent, carbon as reducing agent, calcium as reducing agent. So actually both are used as reducing agent. Say more than aluminium, most of the cases, when you learn the metallurgy chapter in the higher classes, you will understand why actually carbon is more preferred compared to aluminium. Okay, so as of now, just try to remember, more than aluminium, carbon is more preferred reducing agent for reducing moderately reactive metal oxides. Okay, so here more than aluminium is also correct. Okay, but more than aluminium, since carbon has more powerful reducing nature, carbon is used as a reducing agent. So here option C is correct. So option C is correct. So it's a very tricky question. You have to answer carefully. Just remember, more than aluminium, carbon has more reducing power in this case. Okay, fine. 19th question. The highly reactive metals like sodium, potassium, magnesium, etc. are extracted by, read out the options. Electrolysis of their molten chloride, yes or no? So we studied in our syllabus, sodium was extracted from the solution of NaCl, right? So here sodium chloride is a salt form, it's a molten chloride form, right? So similarly, potassium and magnesium also can be extracted in a salt form, in their molten salt form. Okay, so option A only is the correct answer. Option B, electrolysis of their molten oxides, no. Reduction by aluminium, no. Reduction by carbon, no. But here you will have a doubt and confusion between option A and option B, because in both cases they mentioned electrolysis, but in option A it is electrolysis of molten chloride. Say yes, molten chloride, in their chloride form they are extracted, in their salt form they are extracted, not in oxide form, okay, so option A only is the correct answer. Coming to the 20th question, very simple one. Al2O3, it's a reaction. Al2O3 plus NaOH, some reaction here, fill in the blank, plus water. You have to fill what is the product you will get. So Al2O3 on reaction with NaOH, you will get NaAlO2, right? What is the name of this? Sodium aluminate. Right, so very important reactions actually. So now select the option. Yeah, NaAlO2 is mentioned in option C, right? So option C is the correct answer. So that's all about the 20 questions, 20 important questions from metals and non-metals chapter. I think I have covered all the topics here. And one more topic, that is refining of copper. Say try to understand the concept of refining of copper. Questions may ask on refining of copper also. So try to understand the concept so that you will get confidence in attempting MCQs easily, right? And in my next video, I will come up with a chapter, life processes. Till then, take care, keep revising and share the videos to a maximum people. Let everybody get benefit and do subscribe our channel to learn the concepts in the easiest way and in a detailed way. Thank you so much and all the best.